I'm going to present to you the community playbook application demo. I think that we did a couple of times already. So this is already third prototype we're working on. I'm not going to go over all the detail because it's already covered many times. But what we add to the playbook this time is three parts. One is we added the CG analysis and also visualization of outputs, and population dislocation analysis and visualization of outputs. Still, is the city of Joplin is our test case for community playbook application. And on top of it, we added a resilience metrics. I think this is the first time I think we present as a visualization resilience metrics. So I'm going to explain a little bit while we are going in the demo. If you have any question, more detail about analysis or resilience metrics, I think we have all the experts can answer your questions. So I'm going to more answer you about application itself. So now I'm going to switch to my video quick. Okay, so here we go. So as you know, you can log into the system, and we do have a user management systems. You could form the user groups and things like that. And you can see right now, what you see is some of the user interface, but at the same time, this is all those the community playbook content built into web application. So you can see that there's several things going on here. You can see text, list, and table and figures already in the playbook documents. We convert that into the web page here. Now we try to show you how to manage some of the built-in environment and socioeconomic data. So 2.4 step. So you see that there's some of the building inventory data and also electric power facility, and you can see interdependence network data, and then later socioeconomic data set too. So all those information is aligning with the data set definition of INCORE we're currently using. So for example, now you're going to add some information. So you can click the plus sign and then pop up. You can upload the data here. In this case, we try to upload the data of INCORE value loss data we need for population dislocation. So you can select all the proper data type. There's a value loss beta distribution parameter. So you can select the data type and then save. Now the system understands what the data type is. The obviously preparation of data, how to create the data is a separate step than this. You need to prepare that before no data. After that, now you need to define the hazard for the community. In this case, we're defining the tornado. So the tornado model, we are using the INCORE, what it provides. So one is there's a statistical model, or you can use actual polygon of tornado path, or you can use a raster data. You can see now you can give the name of the tornado, scenario tornado, and give them EF rating, and you can pick the start point and the end point of the tornado. And based on the statistical model, it generates the wind field within that path it generates. So you can see that now you can zoom in, it shows the path of the different wind field within the tornado path. And all those tornadoes you created, it managed on that page. After that, now, in order to determine anticipated performance or all the analysis you want to do, you can set up this analysis. You can give name, description. You can pick the building inventory data for Joplin here. And then you can also pick the electric power facility for substation and poles. And there's especially for socioeconomic data, you can pick some of the Joplin related information. And then lastly, you can pick different hazard if you want. You can use an actual data set of polygon, or you can use statistical model one. And then click calculate, and then it does analysis. You can see the running. So it actually updates the status of the job running behind the server side. So now Joplin tornado damage is done now, and then click the expanded, you will see all this output shows. So I'm going to show you the first one, which is resilience matrix one. So you click the view, now you see the resilience matrix. Resilience matrix has a 3 category for now. I believe that we can expand, we can add more. The first one is population stability, and this one shows how the population changes. And the second one is economic stability, and third one is a physical services stability. So first one shows the population stability, especially this output came from population dislocation. So you see that how the household dislocated, you can see that right now by tenure, The number of household dislocated and it shows in the first column. Second is what is the total household. So you are able to compare how much percentage of household dislocated. Second one is by race or ethnicity. You can show the table. And then thirdly is household income levels. Household income level has a different category. That we have five category and unknown, and you can see that. And next one is by housing type. So it's a single family or multi-family. So you're able to see different changes. And also we have the summary, so population dislocation in total, dislocated, not dislocated, and also household dislocation. So you can see number of population or number of household changes. So next step is economic stability. It shows about some measures of how the economy changes before event, after event. So first column, green column row is before events, and also shows the household income. And I can explain a little bit later detail in the CG output. The last one is building damages right now, but we're going to add more physical service stability tables if you're available. Next topic is the interdependency. This is the one shows the relationship between buildings and the substation. So you can see different color cluster building is connected to the centroid of the substation. Using that information, now we're gonna show you the building damage analysis. The damage analysis visualization shows a three-part. On top, there's a bar chart by category or cluster of buildings, and middle, it shows a map, and the bottom shows the table. So you are able to see that most of the building damage happened aligning with the tornado path. And you can also mouse over to the chart. It shows actual value of those information. You have also layer control. You can turn on and off the layer if you want to see more behind the layer so that you're able to turn and off on the layer control. And on bottom shows the building damages. It is categorized by main category, and then there's a subcategories of the building. And then you are able to see different damage state, insignificant, moderate, extensive, and complete. And all those number of buildings it shows up. And the next one I want to show you is the pole damage. So electric power facility has pole damages. So this one is obviously the poles are damaged within the tornado path. So you're able to see that in this visualization. And the next one we want to see is the substation. So to click the view, it shows all the location of substation, and there are 3 substations are impacted by tornado, which is on the tornado path. Next one is a building functionality. You can see this one is without interdependency. So which means that it does not thinking about power availability of building. You're only looking at building damages and then use that information to come up with a building functionality. So as you expected, all this building functionality impacted is aligned with the tornado path here. And bottom of the map is going to show the table. So you can see quickly also by category of the building, but green bar chart shows how much percentage are functional, red is non-functional. Now we're going to see the building functionality with the interdependency. So you will see that now that there are more buildings that are impacted by building functionality because there are 3 substations are impacted. So there are more buildings outside of tornado path that doesn't have a power. So we consider that as a non-functional buildings. So that's why it shows that there's more buildings are impacted by tornado because power is not available. And the same way, you can turn up the visualization and also shows more information about their functionality by percentage of the total buildings for each category. So far, this is we already saw the last prototype. Now we want to get into economic prediction model, which is a CGE model outputs. Click on that area. Now it shows the different economic changes. Now total household income. So you see that there's a bar chart shows a before event and after the event, and also with a table. And another thing is your right side, it has explanation what it means. So what means the total household income and what's a category of the household we shows in the visualization. So that will help you to see that. And also percent change before and after events. And we're going to change into the next result of CG output. The reason we make a drop down is there's so many informations, it's much easier to do that. Second is the domestic supply, similar visualization, a bar chart and table and explanation. So you can see that there is some decrease of the change for each economic sectors in the domestic supply changes. And also definition of each sector is available on the explanation panel. And third one of the CG output or economic changes is employment. Similarly, it shows that employment changes here before and after event. So you can see decrease of employment happened because of the tornado analysis we ran in this time. So you also realize that some of the outputs shows up in the resilience matrix. The last one is a population dislocation. So population dislocation, it shows the heat map of population dislocation on the map. So you can see the heat map here, that which area or the heat that more concentrated in power dislocation of the population happens here. And then below the map, that's the table you already saw in the resilience matrix table, the view. So it shows household dislocation in total and population dislocation in total. And also you are able to show, look at the visualization of table view of household dislocation by different types, categories. You can see that. I think it's going to scroll up a little bit to show the table more. So I think the important part here that is you're able to understand more geospatial map along with this summary of the table, so that they have a more the insight and where the dislocation really happens due to this tornado, and also some of the different category of demographics are impacted by the tornado we analyzing. Okay, last part is that you're going to quickly show that another analysis. Previous one is you run with actual tornado path with a polygon, but this analysis result to briefly show you is tornado with a statistical model we ran. So the reason we show you that is you can run multiple analysis for some depending on your scenario, and then later on you are compare those outputs here. And another thing is download the feature. You can download the output for each analysis. So you download the CSV or shapefile. So you are using that information for your own analysis in Excel or ArcGIS or any GIS application too. So that's the end of the demo. Thank you.